Hello everyone, welcome back to the map of mathematics. In this video we are going to solve this nice algebra problem. Here we have n cubed plus 5n is equal to 42, and we will solve this problem for the values of n. So the very first thing we are going to do is, here first we move this 42 in the left hand side, and you will get the output in the form of n cubed plus 5n minus 42 is equals to 0. So after this I will rewrite this term as n cubed plus 5n. Here we have minus 42, and I can write this minus 42 as minus 27 minus 15 is equal to 0. Now we make the pairs of these terms. So I can pair this n cubed with minus 27, and I can make the pair of 5n with minus 15 is equal to 0. And after this step I can rearrange this term, and we write n cubed minus, here we have 27, and we write 3 cubed, and plus we take common 5 from these terms, and you get n minus 3 is equal to 0. After this step we will use here the nice cubic formula, and you know that if we have a cubed minus b cubed, it is equals to a minus b times of a square plus ab plus b square. Here we have the value of a is n and the value of b is 3, so we put these values of a and b in this nice formula, and you get the output in the form of n minus 3 times of n square plus 3n plus 3 square is equal to 0, plus 3 square, and here you have the remaining terms, which is plus 5 times of n minus 3 is equal to 0. And now you focus on both of the terms, and you see that n minus 3 will be common term from both of the terms, and we can make this as common. So we get n minus 3 times of n square plus 3n plus 9, and here you get plus 5 is equal to 0. And now we can write this as n minus 3 times of n square plus 3n plus 9 plus 5 is equals to 14 is equal to 0. And here we have two cases. The first case is we take n minus 3 is equal to 0, and the other case is we take n square plus 3n plus 14 is equal to 0. So in the first case we get the value of n is 3. So this is the first real root of the given equation. So now in order to find the other real roots, we need to solve this quadratic equation. So now first I will check that this quadratic equation has real roots or not, so that I can use here the discriminant formula. And you know about this discriminant formula. Here we have the value of a is 1, b is 3, and c is 14, and the discriminant delta is equals to b square minus 4 times of ac. So first I will explain little bit about this discriminant formula, and you know about this formula. If this delta is less than 0, then we will say that over this quadratic equation has no real root. Or if this delta is greater than 0, then we say that this quadratic equation has two real roots. And if this delta is equal to 0, then we say that this equation has one real root. So now we will check the behavior of this quadratic equation by putting the values of a, b and c in the delta. So now we put the values of these values in this delta and you get the behavior of delta is equal to, here you have b square, the value of b is 3, so 3 square is 9, minus 4 times of a and c, the value of a is 1, the value of c is 14. And now we simplify these terms and you get 9 minus 14 4s are 56, and 9 minus 56 is equals to minus 47. So here you see that our delta is less than 0. So we say that if this delta is less than 0, then our quadratic equation has no real roots, because here we find only real roots. So it has no real roots, then we will reject it. This case it has no real roots, so we reject it, and we have just only one real root, which is n is equals to 3 be the only real root of this equation. So now in order to check the root, so now we put here n is equal to 3 in the given equation, so that now we check the solution here. To check, I can just put n is equal to 3 in the given equation, and the given equation is n cubed plus 5n is equals to 42. So you put here, it will becomes 3 cubed plus 5 times of 3 is equals to 42, and 3 times of 3 is 27, and 5 times of 3 is 15 is equal to 42, and it will becomes 42 is equal to 42. So this is the our or this expression shows that n is equal to 3 be the only solution of the given equation, and this is the our final answer. So thank you so much for watching this video. Please subscribe to my channel for more exciting videos.